In this video, we are discussing about coordinate system. There are several coordinate systems like Cartesian, polar, cylindrical, and spherical coordinate systems. So now I'm going to give some examples from the day life so it will be easier to understand the coordinate system. Coordinate, which means we are coordinating to reach a specific point. For example, some fishermen they stuck in the middle of the ocean somewhere at this point, and message is passed to the police, and then police has to reach the point B where the boat is stuck and seized and stopped somewhere in the middle of the ocean. So how are they going to reach that point? So in this case, they need some coordinate system. They will follow the system. They can follow any of the system. Let's take in the example of Cartesian system now. Now we discuss about the Cartesian system, one of the system here. So first they will locate, so suppose here is the police station. So here they have the system, Cartesian system. So here is the point and they have to reach, let's take the point 0 and they have to reach the point 1. So what they will do, first they will draw a line, and here you know this blocks, each blocks, right? Each block will have, like in the horizontal they have the scale. So each one box means one unit. It may be 5 kilometer. It depends on their system what they are following. Let's take here 5 kilometers. So at this point they will draw two lines. One is the vertical line from the point P, and here is the horizontal line. And now let's take this, each unit is 5. So here 5, 10, 15, 20, 25, 30 and 35. And here 5, 10, 15, 20. So here the value here on the x-axis they give, and here the y-axis, and the coordinate here, the x and y coordinates. Here what is the value of x? 35. What is the value of y? 20. So at this point they are locating. So what is the, how are they going to reach the point? If they go by 35 kilometers, they will reach at this point on the x-axis. If they follow the y coordinate, they will reach here. So how are they going to reach this point? Now we need the angle. So they will calculate the angle from this. So this angle, suppose if they find it is 30 degree, now they will use the trigonometry, Pythagoras theorem. So how do we use the Pythagoras theorem? They need to get this distance. Let's take r. This is the position vector. Position vector means the location from the origin. From the origin, the location of the point P, the boat, is the position. So they say position vector or the location vector where the police has to reach. So here we are going to find this. So how are they going to find this polar means position vector? Give here A, here B, and here is R. So we know that tan theta or cos theta or sin theta, right? Using sin theta, they can find that is the opposite side over hypotenuse. So opposite side is B, hypotenuse is R. So here the position vector R is equal to B divided by sin theta. So what is b here? B, the length of y-axis, the y coordinate is here 20. So right here 20 over sine theta sine 30. So the value is here 40, which means 40 kilometers from the origin to the location. In this direction they have to go for 40 kilometers above the horizontal. Means here this is the line, horizontal line, and here is the location. So above the horizontal, how much? 30 degree. And even we can find this angle 30. How are they going to find the angle 30? Now example, the formula they use, tan theta is equal to opposite side by adjacent side. Here the opposite side is the y-axis, the y coordinate value is 20, then x coordinate value adjacent side is here how much? 35. So using this tan inverse 20 over 35, they will calculate the angle, and using this angle they can put this value here sine theta later, and then they can find the, now I have given my own value for easy calculation. Oh, this is the concept. So they can find the angle using tan theta to locate the position, means the angle, right? Now sometime we need the three-dimensional coordination, the coordinate system, to locate the position of an object. For example, there is an ant. Now first I am going to draw the three-dimensional axis. Okay, now here if this one is z, here is x, and here is y. How we are going to imagine this is the height of the room. It is our room. It is our room. Here is the height of the room, and these are all the length and breadth of our room. And here is the space, living space, our bed and TV. All the belongings are on the space. This is how we are going to imagine. Now if there is any object, if I want to position an object, suppose here is an object at the point B. So it is locating from the origin on this side of the wall. So let's take 10 centimeter or 10, yeah. If the ant goes closer, so where is the location of the ant now? Just 3 centimeter. Now it reaches here. So what is the location? 0. And where it is? On the y-axis 0. On the x-axis 0. Right? So this is how we plot or we locate an object on the 3 dimension. Right there. So 0, 0, 0, which means ant is right now at this point. Okay. If ant is here, so how are we going to locate this? So it is exactly on the y-axis. How much distance from the origin? So 1, 2, 3, 4, 5, 6, 6 centimeter or 6 kilometer, 6 megameter. It depends on the scaling system. What is scaling? Each unit means the one box. One box is a 1 unit. So this length and breadth. So this is in a unit. So 1 unit is equal to 5 centimeter, which means now the ant is located from the origin on the y-axis of how many centimeters we can calculate. Here is 1, 2, 3, 4, 5, 6. So 6 units are there. So each unit is 5 centimeter. So 6 times 5, 30 centimeter away from the origin in the y-axis. Y-axis means it is on the surface. Now if the ant is moving exactly on the wall in this direction. So what is the ant location now? The location is here, z-axis. 1 2 3 4 5 5 units. So 5 units, each unit is 5 centimeter, so it is 25 centimeter above the x-axis, oh sorry, z-axis, right? So it is the location that we find. Sometime what happens, if let's take this moves here, this ant is on the wall in the height, here is the wall, the vertical height of the wall. Now here is the, here at this point is the ant. So we are going to locate this. How are we going to locate here? So first we need to find the x value, y value and z value, right? So what is the x and y value? Now we have to project this onto the y axis like this. So now I am going to locate, I'm going to locate the position of an ant. So before that I want to erase this, so it will be easier for us to understand. Okay, okay, fine. Now here is the position of an ant. So I'm going to locate this. Now it is on the wall, it is on the vertical wall. So how I'm going to locate? So I have to go this much distance on the y-axis and this much distance on the z-axis. So here I can find the y-axis value 1 2 3 4. So 4 units are there. So I told you each unit is scaled as a 5 centimeters. So 4 into 5, 20 centimeter. I have to go on the y-axis and check the x value 1 2 3 4 5. So 5 into 5, 25 centimeter on the x-axis, z-axis. So I go 25. Then I can reach the location of an ant. So this is the case for the ant. So it is almost like a two dimension because it is on the surface of the height of the wall. This is a two dimension. So what if we need to know the fly, housefly, the location of housefly? Housefly sometime it is on the surface of the wall, so two dimension is enough. But if it flies and if it is at the middle of the room, somewhere up in the location, some location inside the room, in our room, so we need three dimension. How are we going to locate this three dimension? So we have some another graph, three dimension graph. It will be easier to understand. This is our three dimension graph. Now we are going to locate the point. Now the red point, you can see it is where it is now. It is exactly at the origin. So the coordinate here x y z is 0. So the location is at the origin. Now the fly is now on the wall or on the floor. So you can see here, this is the floor where this surface xy floor xy. So now I want to move the point. So you assume this red mark is a ant or the fly. Now it is moving. Now the coordinate value x y z 0 0 0. Now I will increase, now 1. Now you can see 1 and it is moving to 3 4 5 6 7 8 9 10. So each unit is 5 centimeter. So how many centimeter the house fly is located and which direction and which axis? It is on the x-axis. It is on the x-axis. You can see positive x-axis. So here 50 centimeter away from this origin. 50 centimeter. Okay, now it goes back, it goes back, and now we can say it is on the negative x-axis on 5 unit. So 5 times 5, 25. Okay, now it goes back. So what is the location? 0. X-axis is 0, y is 0, z 0. So the coordinates 0, 0, 0. Okay, let's take now, it is moving to the on the surface. So it is 5 units are here on the x-axis, and it is going to another point that is on the floor. Just you assume xy plane is our floor, okay, on the ground. So now you can see here 5 units, that means 25 centimeter, 1 2 3, 3 units, 4 5, 5 centimeter, that for 5 units 25 centimeter again. So from x-axis 25, y-axis 25. Let's now it is starting, it start to fly. 1 unit up, 2 unit up, 3 unit up, 4 5 unit up. Now let's see how it is on the z-axis. So now here is the case. So you can see now it is above the ground. So how much above the ground? 5 units above the ground. 5 units above the ground. So again it flies up. 6 unit, 7 unit, 8 unit, 9 unit. So what is the x coordinate value? We can see the x coordinate value here. Here is the x coordinate value. It is projected on. If you project this, here is the x coordinate value, 5 units, and here y coordinate value and z coordinate value on the top. So this is how. Now suppose if it is coming down, the fly is coming down. Now it is on the ground. Now it is going closer to the origin, like that. So it is like this. X-axis 10 units are there from the origin, and y-axis 5 units are there. So what is the value from the origin? X-axis value 10 into 5, 50. From here to here 50, and here to here 25. So here is the location in the x-axis and y-axis. If you want to find the exact location, what you can do, you can draw a line from the origin and reach here, right? So this is the position vector, and using the Pythagoras theorem, draw a line, a vertical line to the axis, and there will be the angle, and you can find the opposite side by hypotenuse, or tan theta, opposite side by adjacent side. Opposite side is here 25 centimeter, adjacent side is here 50 centimeter. So tan inverse, theta is equal to tan inverse the opposite side 25 over adjacent side 50, 25 over 50. So you can find the angle. And if you want to reach this point, you have to go from the horizontal surface, the angle, this much angle, to reach the point P. So in this video we discuss about the Cartesian coordinate in detail, and then the next video I'm going to give a good detail about spherical coordinate, and then how to transform from the Cartesian coordinate to spherical coordinate. Thank you for watching.